Hello. So hello everyone. Welcome to today's tutorial of week 9 for the engineering mathematics 2. So this is Rahuldev from School of Mathematics at Thiruvananthapuram. So as it is written for week 9, so we'll do mainly the problem sheet from week 9, problem assignment sheet 9. Okay, mainly we'll be solving those, and if time permits we will do more things also, but mainly on assignment 9. Okay, so I wait for 1 or 2 minutes to, as it's live session, it's recording, so I'll wait for 1 or 2 minutes, maximum 2 minutes, for others to join, then otherwise I'll start. Okay. Yeah, so in the previous like previous tutorial, we studied, we solved some problems on uh, sorry, Fourier series, right? So we did things on Fourier series. So this was on the previous tutorial, which if you remember, that was mainly for periodic functions. Here the Fourier integral, when we talk about that, we can talk about for the functions which are not periodic also. Okay, so it is kind of generalization, and generalization to non-periodic function also, you can think like that way. Okay, so as I should not do all those verification and all, what I am saying, I should only do whatever is needed for your course. So that is, if you the like if you write the Fourier integral, so mainly what we write in the Fourier complex form of the Fourier series, any functions, and we can, it's like one can write a periodic function. So if Cn e to the power I pi n x over L, okay, with Cn is given by 1 over 2L minus L to L fx e to the power minus I pi nx over L, right? And also one know from here that you can write this uh, L2 norm of f, that is precisely given by 2L summation over n c n square. This is also very known, I think, Parseval inequality, if I remember. Okay, so from here one can write. So this is the question, but yeah, before, don't look at the question. No, what I'm saying is, from here, formally taking L equal to L tends to infinity, so one can get the Fourier integral formula, which is like fx, you can write like minus infinity to infinity Fourier transform of that function times e to the power I omega x d omega. Okay, what is omega? Omega is a dummy variable which we get mainly from w equal to pi n by L by substituting. Okay, and like mainly what I'm trying to say, this comes from Fourier series, and at the end what you can write this representation more precisely in your, for your course, that is given by fx is equal to 0 to infinity uh, a omega, 0 to infinity or minus infinity to infinity, whichever you want, you can take like that. Minus infinity is a omega f x a omega times, sorry, a omega times cos omega x plus b omega times sin omega x, where a omega is given by 1 over pi minus infinity to infinity fx. A omega should be sin omega x, right? Sorry, cos omega x, and b omega would be 1 over pi minus infinity to infinity fx sin x. dx, of course, dx. Mainly, if this is a Fourier like transform formula, sorry, Fourier integral form of this function fx, and here also you can say that fx square minus infinity to infinity dx will be 5 times 0 to infinity a omega square plus b omega square d omega, of course. So what I'm trying to say, the similar properties you can obtain, okay, for this type of equation, this type of Fourier integral representation of the function. Now the function is, see, everything is already said to you, right? That fx will be minus infinity to infinity. Yeah, the formula, everything is said. So now we have to find for this question. Now comes to this question one. Question, the coefficient of a omega is the Fourier integral representation of the function fx. So function is given. Need to find out a alpha. See, here I wrote a gamma, but sorry, a omega, but you can find out. Here it is, as it is said, a alpha will start with a alpha. What is that? A alpha would be, so 1 over pi minus infinity to infinity. What is now fx value? Fx will take pi over 2 sine x, right? Pi over 2 sine x. And as it is a alpha, it will be cos of alpha x dx, right? What is that thing? 1 over 2 pi by 2 will get cancelled, but you see pi by 2 sine x, pi by 2 times sine x only in minus pi by 2 pi by 2. Outside that it will be 0. So what you can write, this integration is nothing but, no, if I write precisely, I'll keep it fx here, keep fx here, and then I write in the second step pi by 2 sine x cos alpha x dx, because the fx will be non-zero only in the minus pi by 2 to pi by 2 region, otherwise it will be 0. So you don't need to take into consideration. Okay, now what is the formula for this? Sine a cos b, right? What's the formula for this? If you remember this formula, it will be sine of a plus b plus sine of a minus b, right, over 2, right? Sine of a plus b, I mean sine a cos b, 2 times sine of cos sine a cos b is nothing but this, right? So if I use this formula, this is formula, let's keep it. So then it will be half minus pi by 2 to pi by 2. Now sine a b, a is x, sorry, a is x, b is alpha x, right? So 1 by 2 first of it will come, then x plus alpha x plus sine of x minus alpha x dx. What it gets, 1 over 4 minus pi by 2 to pi by 2 sine of x plus alpha x plus sine of x minus alpha x dx equal to 0. Why? The question is why just it is 0. Remember, alpha minus a to a
of minus a to a, integration from minus a to a fx dx is equal to 0 if the function is odd, right? Here sine function is odd. So as the sine function is odd, so we get, and the addition of two sine functions are there. Addition of two odd functions will be odd again, and thus we get uh, the integral value is equal to 0. It's independent of alpha. We started with alpha a alpha. So the second option is correct, right? So you will have the solution also here, which says this, and that's why it is 0. Correct answer is 0. Okay. We'll move to the next question. The coefficient of b alpha in the Fourier series, Fourier integral representation of this function. So this will be also doable, like similarly we did. I thought people will be here, and they can practice here, but nobody is here. So what you do, you try at home. Like most probably will be watching the YouTube videos, which I will upload. What you can do, you pause the video and try. Okay, here I will be doing, but you should not just look at it. Okay, you just try first, then do it, and you find where you get stuck. Okay, so you try to improve that. So this will be also is easy. B alpha, what is the formula? Will be 1 over pi, right? So 1 over pi integration of minus infinity to infinity, but in this case, because integration has fx, if fx is 0, the integral value is 0. So fx in x greater than 2 means x greater than 2 or x greater than, sorry, less than minus 2, right? So when in this region you have, when you are in this region, then the function value is 0. So only I will consider from minus 2 to 2. Okay, minus 2 to 2, minus 2 to 2, 3x over 2 function value times what will, for b alpha it will be sine of alpha x, right? So mainly we need to evaluate this integral, right? Okay, so what we will do first, that implies b alpha equal to 3 over 2 pi minus 2 to 2 x sine alpha x, right? Yeah, so again this one you can write as, now you can think this as okay, 3 over pi 0 to 2 x sine alpha x. Hopefully you understand why it is, right? Because this is a even function. You can write like 0 to minus a to a fx will be 2 times 0 to a fx dx if f is even function. Okay, so I have used that here. So now 3 over pi I keep as it is. Now I use integration by formula, integration by parts formula. Okay, to obtain, so x times what will be sine alpha x, or the minus cos alpha x derivative will be sine alpha x, right? So then it will be minus cos alpha x over alpha, right? Now minus integration over. So first of all, derivative of x, that is 1, and then again minus cos alpha x over alpha dx. That limit I will take from 0 to 2. So thus that is equal to 3 over pi okay, so minus x cos alpha x over alpha plus sin alpha x over alpha square 0 to 2. That will be equal to 3 over pi. When I put 2, that will be 2 cos 2 alpha over 2 plus sin 2 alpha over alpha square minus 0. So it will be just only this. That will be equal to 3 over okay, so I have missed something, so that is this is will be as it is alpha, right? So when I take 3 over alpha square pi, why I am taking like this, you will understand. Then it will be sin 2 alpha minus 2 alpha cos 2 alpha, so that it looks like our given options. See, 3 over pi alpha square everyone has, this one, this one, this one, but answer should be sin 2 alpha minus 2 cos 2 alpha. So first one is correct, others are not correct, right? That's how it will be. So answer is also given. Now I'll move to the next one, which is little different than what we did first two. Using Fourier cosine integral of fx equal to e to the power minus 6, the value of this. If you look it closely, it is kind of like a alpha, b alpha, that type of, right? Fx equal to what we do, fx equal to uh, f alpha cos alpha x d alpha, like that, right? So that alpha, a alpha, b alphas type of things are there. See, a alpha is kind of your alpha dependence, right? And that type of equation, mainly that type of thing you have to mainly find out there. So here also you see this is not a alpha, but here you will see a alpha. A alphas are like this, right? Integration form. So that type of thing mainly you have to find out. That's why it is given. Like that's why you can use the Fourier cosine integral and then find out the uh, most probably this a alpha should be 1 over 1 plus alpha square, right? Then it will be a alpha cos alpha x. You need to find out that is 0 to infinity, right? So the Fourier cosine integral, if you write of the function, that will be, I mean, not equal to, mainly people write like this approximation alpha cos alpha x dx. And but in this case, as the another term is not a, so one should write it as uh, 2 over pi instead of 1 over pi, okay? So sorry, not because of that. So 0 to infinity, I'll write it as 0 to infinity a f of alpha, right? What is f of, sorry, f of x, f of x cos alpha x dx, right? That is nothing but 2 over pi 0 to infinity e to the power minus x cos alpha x dx. That is nothing but 2 over pi. What is the formula for this? Yes. Okay, I also forgot, I think. So what is the formula for this e to the power because e to the power minus x, unlike x and x square, all those things, it don't just get vanish, or like the derivative won't, the complexity of derivative won't decrease, right? It will keep on going, right? E to the power minus x. So that's why it is difficult to say that what is the value for this by simple integration by parts. Okay, so one need to mainly remember the formula for e to the power ax cos bx integration value, right? So if you do that, it will be e to the power ax over a square plus b square of a cos bx plus b sin ax, sorry, sin b sin bx. I think this is the formula is available. Okay, then if you use that, then it will be here it is a is minus 1, right? So e to the power minus x over this a is minus 1 means minus 1 square will be 1, and b is alpha, so alpha square times a is minus 1, so minus cos alpha x, and b is alpha plus alpha sin alpha x, that will be 2 e to the power minus x over pi times 1 plus alpha square alpha sin alpha x minus cos alpha x. Okay, okay, so that's not the thing you need to find out. Okay, need to find out mainly a alpha cos alpha x, right? Okay, still it's not done. So that is from 0 to infinity, right? Yeah, I haven't derived that thing. Yeah, it's not, it should not be x dependent. So 0 to infinity, right? So when you put infinity, e to the power minus x becomes 0, right? So but and this one you don't know, but this is a bounded function, and e to the power minus x converts to 0. So as x tends to infinity, this will vanish to go to 0. But when only x equal to 0, then the value is 2 times e to the power negative of 2 times e to the power minus 0 over pi times 1 plus alpha square times 0 minus 1, because cos takes value 1. So that is 2 over pi times 1 plus alpha square. Okay, so thus fx, as we wrote, fx can be written as 0 to infinity a alpha cos, sorry, not cos, right, sin alpha x. Oh, no, sorry, a alpha times cos alpha x, right? Already we wrote. So dx, sorry, d alpha, that is equal to 0 to infinity 2 over pi times 1 plus alpha square cos alpha x d alpha. See what we need to find out, only cos alpha x over 1 plus alpha square. So uh, 2 over pi times, this is the thing we need to, we were supposed to find pi, sorry, 1 plus alpha square d alpha. So that implies 0 to infinity cos alpha x over 1 plus alpha square dx will be pi fx over 2, right? What's the value of fx? That is e to the power minus x, right? E to the power minus x is e to the power minus x over 2. So that will be the answer then. Pi e to the power minus x, pi e to the power minus x over 2. So this is the answer. Yes. Answer will be this, right? Okay, so that was the answer for Third question, solution is also given here. Okay, so one thing is, if you find mistakes, so please let me know, because you are not here. I mean, you are not joining in the live session. But if you find any mistakes in while going through the recording videos, please let me know, at least like through mail, or if it is in YouTube itself, anywhere is okay. I will check and I'll reply. I'll try to like give clarification of those mistakes or doubts, depending on the like what you ask. Okay, so it will be good then. If something is wrong, yeah, it can be wrong also. If sometime it can be wrong, so then let me know. Okay, so the thing is, see, it is not easy to find out maybe the whether I am teaching wrong. So you try to ask question. You ask whenever you ask question, then I will understand. Like, but maybe if you ask 10 questions, then one of them would be I am wrong. Like I did wrong, that's why you did not understand. That can happen, right? So yeah, try to ask question, and then you will find out. If I cannot give answer, I'll think that I will have to go through and I'll see maybe it's I did whatever I did that is wrong. So try to ask question. If you have doubt, any doubt, you just try to ask. So here now we'll come to the question 4. Which of the following is true for the function fx equal to 2x minus 3x cube in minus pi by 4 to pi by 4. So you know this 2x minus x cube, if you put, see, it's first option is asking whether it is odd function or not. To so it is odd function, we start with f of minus x, that will be minus 2x plus 3x cube, which will be negative. If you take common, it's exactly same as the function fx, so it is odd function, right? That's the definition of odd function. So this is odd, and once one function is odd, it cannot be even, right? Unless it is the zero function, right? You can check it. So the Fourier integral representation of f is a Fourier sine integral, or it is Fourier cosine integral. What it is? So how to understand that? So mainly what you just look is what is fx. Fx is, if you remember, fx will be 0 to infinity a alpha cos alpha x d alpha plus b alpha sin alpha x total, sorry, alpha times x here, of course, just total d alpha, right? Okay, alpha x d alpha, right? So when it will be sine integral or cos integral, depending on a alpha and b alpha values. So what is a alpha? You see, a alpha is 1 over pi, right? A alpha is 1 over pi minus infinity to infinity, right? Minus infinity to infinity, fx cos alpha x, but alpha x dx. Okay, what is f of fx is odd function, right? So when fx is odd function, f of minus x times cos of, I'm thinking about this function now. This function cos of minus x means times minus x. Let me write it properly, precisely. Alpha times minus x, that is equal to, as this is odd function, it will be minus of alpha x, and this one will be cos of alpha x, because cos is even function. But total thing, it becomes as this function. If you think about this function as gx, this function become, this is gx. So gx, I started with g of minus x, right? That is minus of gx, right? That means it is odd function, right? So for odd function minus infinity to infinity, then it will be 0. So a alpha for any, so what the thing I needed, only I used the property of the function f is odd. So when f is odd, cos alpha x will always be there for any function, right? So when f is odd, fx times cos of alpha x will be odd. And sorry, yeah, fx times cos alpha x will be odd. And then a alpha will be 0. So once a alpha is 0, so b alpha won't be 0. If it is 0, then both are 0. So b alpha is, I will be having sine of alpha x. So the integral value might be 0, but not always 0. But what thing is 0 is a alpha is equal to 0. Once a alpha is equal to 0, so fx from this, what you can write, fx nothing but 0 to infinity b alpha sine of alpha x only, right? So it is nothing but sine integral, not cosine integral. So 1 and 3 are correct. Is it okay? I mean, it should be okay, because just yeah, this is a good thing also. I mean, it's easy but nice observation you can have, like that any function which are odd, the odd functions will have Fourier sine integral only, because the cosine integral, the coefficient of the cosine integral part will vanish. Okay, so knowing this, we'll move to the yeah, this is a solution, and then we'll move to the fifth question. The Fourier cosine transformation is this, that Fourier sine transformation will be what? Okay, so you need to know about what is Fourier cosine transformation and sine transformation, right? So mainly, okay, so Fourier sine transformation fs of fx is given by square root over 2 pi 0 to infinity fx sine alpha x dx. It will come in terms of alpha, right? Yeah. This is transformation. Okay. Fourier cosine transformation comes here. They are not equal. This integral and the transformation. Okay. So the question is, what is the difference first of all? So mainly we write the Fourier integral as 0 to infinity a alpha cos alpha t, so or cos alpha x plus b alpha sin alpha x dx. Fourier integral. Okay, any function you can represent like that. And the Fourier transformation is will be given by this 1 over square root of pi ft, sorry, fx sin alpha x, or it is cos alpha x, like that. I mean, whatever way you want. But this question is doable by the formula, right? That is not a problem. So I just wanted to say what are the things behind this Fourier transformation and Fourier integral. Okay, mainly they should be related. Okay, so one can obtain from Fourier series to Fourier integral that I showed, right? Fourier series to Fourier integral one can obtain, and using that one can solve many problems, right? Like this last one you solved, right? That was not easy just by using usual formula. See, this value of this integration cos alpha x over 1 plus alpha square x times, you just take x equal to 1 also, that is not a problem. But how do you solve this cos alpha over 1 plus alpha square 0 to infinity interval? Those are not easy. So if you just use this, you can obtain. Okay, those are okay, but the thing is, why, like why the Fourier transformation, like not why, like how they are related, any relation is there between them? Okay, so what they say is, mainly you can write this fx as minus infinity to infinity, right? Some okay, fx, what you can write, f alpha times e to the power minus I alpha x dx, right? Sorry, not dx, d alpha, d alpha. So minus infinity into f alpha e to the power minus I alpha x. I mean that f should be the Fourier, like that is Fourier transformation of the function. Okay. So now this f alpha, So Fourier, what is Fourier integral function? So Fourier integral function was like this. So you take this something like this. So minus some coefficient is there. I'm leaving that coefficient now. If alpha, if x e to the power minus I alpha x dx, right? That will depend on alpha. So that was the complex representation, right? And once we have this, now you can use this fx. Also again it can be written as that a alpha cos alpha x, b alpha sine so fx one can write as minus infinity to infinity this some fv e to the power minus I xv dv, right? So knowing this, if you put it this fx here, then it will be fv minus infinity to infinity fv e to the power minus ixv dv times outside it will be e to the minus I alpha x dx. By doing some like integration properties using this, what you can write this 1 minus infinity to infinity 1 over square. So the square root of 2 pi will be coming because of this another 1 over 2 pi is there. So it will, if you start with 1 over 2 pi 1 over 2 pi, so things will be like this 1 over 2 pi minus infinity to infinity, this will interchange and it will be fv e to the power minus iv alpha dx times e to the power iwx dx, and we say this one as the Fourier transformation of the function fx. Okay, so that you can little bit go through. If you have doubt, you tell me. Okay, that was a kind of just hand waving argument I gave. Most probably it is like it should be like that, but it's not rigorous still. Like rigorously you might not understand, but it comes from, yeah, that's what I was wondering, whether it comes from Fourier integral formula or not. Okay, Fourier integral, Fourier series, Fourier series and integral form and Fourier transform are closely related. Okay, that's what I wanted to say, related. Okay, so now how to solve this question? Okay, the question is the Fourier sine transformation is given to you. Fourier cosine transformation, cosine transformation is given to you. What is that? Fc of e to the power minus 2x is equal to alpha over 4 plus alpha square. Right? Need to find mainly fs of 2 e to the power minus 2x. So now you have to remember that fs of the derivative of a function f prime x will be minus alpha times fc f of x. This is very important to remember. Okay, so then once we know this, then what is this function and this function relation? This is f, then this will be f prime, right? So then fs of e to the power minus 2x prime, I mean the derivative of that, equal to minus alpha fc of e to the power minus 2x. You know this, right? And this is nothing but fs of minus 2 e to the power minus 2x equal to minus alpha. What is fc of this? It is given by alpha over 4 plus alpha square. That is nothing but minus of alpha square over 4 plus alpha square. Right? That implies the options, which one will be correct? Then the first one is correct, right? Minus alpha square by 4 plus alpha square. This is not correct, this is not correct, this is not correct. If you see the solution 5, the exactly same thing is written. And then I will move to the next question. You read and then we'll do. Okay. So pause the video and read for once or twice. Consider that Fourier transformation f alpha is equal to minus infinity to infinity fx e to the power I to alpha pi x dx of a transformation fx. Then what will be the Fourier inverse transformation of f? I mean, this is nothing to do. You just, when you have Fourier transformation f alpha, the inverse transformation will be given by, I mean, this is a theory, like minus infinity to infinity. You just, instead of fx, see, instead of capital F alpha, I put fx. So instead of fx, that's why I will put f alpha. Not that's why, it's just remember like that. And then it will be, instead of e to the power I 2 pi x, it will be negative of I 2 pi x. That's all. 2 pi alpha x, and in this case it should, of course it should be d alpha, because the f is depending on x. So that was just a theoretical question, there is nothing to do with that. So f alpha e to the power minus I2 alpha, as whatever the alpha coefficient will be there, that will be the, again, negative of that will be the answer, negative of that will be in the inverse. Okay, that was nothing to do with this. Okay, so this is okay. Now I'll move to this one. So this one will be little good. I mean, good mean, see, the integral value you need to find out is not easy. But once you know, if also know some other property of Fourier transformation, you can find out this integral very easily. Okay, so how to solve this one? Okay, okay. So the thing is, you see something. So f alpha, how it is given? F alpha is 2 over pi 1 minus cos alpha over alpha square, and you need to find 0 to infinity sine to the power 4 t over t to the power 4. Okay, or sine to the power 4 alpha alpha to the power 4 d alpha, in this case dt, right? And you know this f alpha is Fourier transformation, right? So for using inverse Fourier transform, what you can write minus into infinity f alpha e to the power minus 2 pi alpha x I 2 pi alpha x. So whatever is that, 2 or 2 is there or not, no matter also. So fx square minus infinity to infinity will be then of dx will be f alpha square minus infinity to infinity minus infinity to infinity f alpha square d alpha. It was d alpha here, right? So what is that? That is nothing but minus infinity to infinity 2 over pi 1 minus cos alpha whole square over alpha to the power 4 d alpha, right? If I write it now in the better way, 1 minus cos alpha whole square over alpha to the power 4 equal to times d alpha equal to pi over 2 minus infinity to infinity fx whole square dx. Now see 1 minus cos alpha is nothing but 2 sine square alpha by 2, right? And now I take whole square as it was, d alpha is equal to pi over 2 minus infinity to infinity. Now time comes to see what is the function fx. Fx is 1 minus modulus of x when modulus x is less than 1, and when modulus less x is greater than equal to 1, then it is 0. So I will consider only from then minus 1 to 1, right? Yeah, so instead of minus infinity to infinity, I'll only consider from minus 1 to 1. What is fx? 1 minus mod x, that whole square dx, right? And here what you are getting is 4 times minus infinity to infinity. The okay, I think this is what you need, or no, no, no. Yeah, I mean some problem is there, so like it's not exactly the thing which we need. No, let this is alpha by 2. Okay, alpha by 2, right, over alpha to the power 4 d alpha, right? That's all here. So then what you have is equal to pi over 2. Now you see modulus of x does not is equal, is you cannot do like integration as usual. So what I do, minus 1 to 0 1 minus what is modulus of x when 0 to minus 1, it will be negative of x, so that is 1 plus x whole square plus pi by 2 times 0 to 1 1 minus x whole square dx, right? That implies 4. In this integration value, I take alpha by 2 is equal to z, sorry, alpha by 2 equal to t, then sine alpha to the power 4 t over alpha by 2 is equal to t, so it will be 2 to the power 4 t to the power 4, right, times 2 dt, alpha equal to 2t, right? So 2 dt, is equal to pi over 2 x plus 1 whole cube over 3 minus 1 to 0 plus pi by 2 x minus 1 whole cube over 3 0 to 1, that is equal to pi by 2 2 cube, sorry, 1 over 3 minus pi by 2 minus 1 whole cube again, so it will be 1 over 3. So what does that imply? Here 2 2 and 2 2 square, that will give you 1 over 2, and that will go inside. So here minus infinity to infinity sin to the power 4 t over t to the power 4 dt will be equal to, then it was like this, so it will be equal to then pi over 3 and pi over 3, right? 2 pi over 3 total, it should give then 2 pi over 3 equal to 2 pi over 3, and that is, I think, the third one. So third one will be correct, and just check whether I have done it correctly. Okay, so yeah, the answer is also given. Just check it here. Now we'll move to the, we can say, next part or the last part of the talk of the tutorial session. If the Fourier transformation of v of x is given by fv, then what can you say about the second derivative and the first derivative of the function? Okay, this is a Fourier transformation of the vx. So what will be the second derivative of the what will be the Fourier transformation of the second derivative and the first derivative? Okay, that's the question mainly. Okay, so for that, so what do you know about f of v? F of v is given by 1 over square root of 2 pi minus infinity to infinity vx or xt, right? Vx is treat it as a function of x itself, so that's not an issue. V Vx e to the power minus I alpha x dx. So what will be then del v del x? That will be 1 over square root of 2 pi minus infinity to infinity. It will just del v del x times e to the power minus I alpha x dx, right? So now you just try to find out what is, so minus infinity to infinity del v del x e to the power minus I alpha x dx. That if you take integration by parts, uh, it will be, so first I will take this v into the factor, so it will be del v del x. So I'll take e to the power minus I alpha x as the first function, and then it will be then v, right? So first the negative of e to the power integration, I will take integration of e to the power minus I alpha x. So that will give you minus I alpha. So I can take plus I alpha, and alpha and I, they are constants. So that is not an big issue. Then times it will be again v, right? Dx. But it is from minus infinity to infinity. So what does that give you? That is nothing but, if you take this one, e to the power minus I alpha x times b, that is from minus infinity to infinity, plus I alpha minus infinity to infinity, kind of v e to the power minus I alpha x dx. B will be at x. Now what about this minus infinity to infinity e to the power minus I alpha x times v? Whether it will be like something, and this one you know it is f of v, right? So what we got, e to the power minus I alpha x vx, which is from minus infinity to infinity plus I alpha times f of v. And we started with, this is nothing but f of del v del x, that is equal to this, and then it is coming like this. So this Vx, I think there should be another information. If at infinity and minus infinity, they are like f vx converts to 0 as x tends to minus infinity plus minus infinity. So that I think that should be there. So if it is not there in I don't know how to then solve it, okay? Because this one, it will not be just 0 somehow, okay? Because the answer wants this to be 0, because you will see only I alpha f with that type of terms are there, okay? So, but this one will be a constant. So constant plus something cannot be, right? The answer, because the answer is only like this I alpha f v or something. So if you assume here Vx converts to 0 as x tends to plus minus infinity, then as e to the power minus I alpha x, that is a bounded function, right? Because cos alpha x plus I sin alpha x, that is a bounded function. So this will be then I alpha f of v. But I would say it is after assuming this condition. I don't find now as a easier one that which will say that it is equal to 0, okay? But once you assume this fact, this assumption once you have, then you can say that this assumption, you can say that this is okay. So then the next one also it will be easier. So f of del to v del x, that will be then equal to I alpha times, again I alpha will come into the picture, so which will give you minus alpha square times, because that is f of v alpha, that is nothing but f of I del to alpha is I alpha f of del v del x, right? That is equal to I alpha times I alpha f of v, that is nothing but minus alpha square f of v. Yeah. So it was written here just like I alpha times f of b, but why it is 0 it was not explained, that I assume that f vx, okay? And then you can do that. Now we'll move to the 9th question. If the Fourier transformation of e to the power minus 2x is given like this, then what is the value of this one? Okay, so this is a formula given by, so first of all you see that e to the power e to the power minus 2 times mod x, and e to the power this, if you assume this is as fx, then f of x minus 2 will be this function f of e to the power minus 2 mod x, that is just sorry, this will be x minus 2, okay? That is something nothing but translation. Now you assume this as gx, okay? Then what you need to find f of fx, this is convolution product, something called gx, that will be nothing but f of, that is easy, f of fx star, this is not this is now this is not convolution product, this is a product, convolution product and product. Now this is f of gx. Okay, so you need to know about the convolution product, then you can check some like everywhere it will be available. Okay, that's not a big deal. Okay, so fx convolution gx or f convolution g of x is given by integral. Okay, integral. So anyway, you need to know about this. Okay, now if you know f of what is f of fx is given already 4 over 4 plus alpha square. Okay, so you need to know if f star z of x, in case you need to know, that will be minus infinity to infinity f of some f of eta g of x minus eta d eta. Okay, that is but it's not needed here. Okay, okay, so now what is this f of dot product with f of what is gx? Gx is nothing but f of x minus 2. So there is another thing you remember, f of x minus some a, if you translate it, it will be changed by e to the power I a alpha times f of fx. Okay, so 4 by 4 plus alpha square times e to the power I 2 I times 2 times alpha times f of alpha. So that will be 4 over 4 plus alpha square. Okay, this is square root of 2 pi will be also there. Square root of 2 pi, square root of 2 pi equal to square root of 2 pi 16 over 4 plus alpha square whole square times e to the power 2i alpha. How the answer is given? 2i alpha 16 square root 2 pi. Yeah, so that is nothing but you can write square root 2 pi over 4 plus alpha square whole square times 2i alpha. That's all. Fourth option will be correct one. See. Okay, so I'll move to the last question, and as nobody is here till now, so I will finish by doing this one. And this is very easy one. So the Fourier cosine transform, as we denote it like this, that is given by 2 over pi alpha over 1 plus alpha square. Okay, okay, let me write maybe here.
fc of fx is given by square root of 2 over pi alpha by 1 plus alpha square. Right? So what you need to find? Fourier transformation of. So immediately you need to remember this fc of f of ax will be equal to 1 over modulus of a. Of course, a is not equal to 0. I need to find times Fourier cosine transformation of the function f. So that is fc f of x. Okay, so there is a little catch. So instead of fc of f of x, that would be whatever that function that will depend on f of alpha. See, this type of forms are depending on f of alpha. So that f I denote it by fc of alpha, right? One can denote because it depends on alpha. So then that fc of alpha over a it will be. Okay, so now in this case fc of f of 5x is we need to find out. That will be given by 1 over modulus of 5, that is 5 fc of x alpha over a. So what is that? So alpha over 5 it will be. So square root of 2 over pi alpha over 5 over 1 plus alpha over 5 whole square. So that is given by this. So that will be 1 over 5 square root of 2 over pi. So 5 alpha 25 plus alpha square, right? Yeah, so that is given by square root of 2 over pi equal to square root of 2 over pi alpha over 25 plus alpha square. 25 plus alpha square. Square root of 5 2 pi. So third answer should be correct, right? So here you see I have given the answer also. Yeah, a is not equal to 0 for that, equal to 5. Only thing is this will be 3 instead of c. Okay, let me just do this one. 3. Okay. Okay, so that's all for today's session. We'll see in the next Saturday. So remember that I think there is a mistake in mistake or something. I don't know, but my classes are scheduled on Saturdays. From 3 p.m. to 5 p.m. Okay, remember that class time. So in case you don't know, just I'm just giving it here, just writing it here, and yeah. So we'll have last 3 classes. Okay, these are books and references, and then thank you for attendance.